deep breath. Now, there are many ways to talk about a distribution. So you could, for example, talk about, minutes, right? Which is the unit that we're using here in this particular situation. Because we're doing wait time. Wait time is measured in minutes. Whatever unit you're using to measure your question, you can use the unit of the question that you're measuring. So here it's minutes. But you could also use this other measure called standard deviations away from the mean and cumulative. We're gonna talk about all of them. So don't worry too much. We're gonna start with these two first. Okay. So the z-scores and standard deviations away from the mean, they're pretty much the same thing. Okay. You can see that the numbers are exactly the same because the point at +1 z-score, is the point that's also one standard deviation above the mean. Why? Because it's a point of number 65, and 65 is a point one standard deviation above the mean. Why? Because the standard deviation was built to fit the ruler. It's kind of like self-referential and confusing, but I hope this makes sense visually. So the point at one standard deviation above the mean, which is represented by this red bar, right, is the point right at z-score of +1, which is the first bar. Okay, so hopefully this makes sense at this point. Okay, that's the distance, that's the first bar. And the point at 2 standard deviations above the mean is the point of z-score +2, which is the second bar. Okay? Okay. Now, let's move on. Let's talk about some other things. So we all know that 34% of the people, waited between 60 and 65 minutes because we got it from, the distribution, right? This is this other sort of measure that you can use, which is the probability of cases in portions of the curve. Man, very long name to just say this is the area of, total area of the curve. When you calculate the area of a triangle, like in high school, remember, like, oh yeah, it's like the height times the width divided by 2 or whatever. It's the same thing that we're doing here. We're calculating the area of this distribution. So this area highlighted here accounts for 34% of the total area of the curve. But wait, oh no, oh, where did you get this 34% from, man? Like, where did you get it from? Oh, I got it from there. I just told you. I got it from there. It's right there because it's a ruler, And then you're like, it's the point between this bar and this bar. And it says here the point between this bar and this bar is 34%. Okay. And the point between this bar and this bar is 13.5%, as you can see here in the number. No, but wait, no. Where did you get this from? No, I'm so lost. No. Man, think about this. The normal distribution is like a ruler. Okay. Let me give you an example of how we use a ruler. Okay. It's actually pretty simple. Let's say you want to measure a pen. Okay. How do you measure a pen? You get the pen, you put the ruler next to the pen, and then you measure the height of the pen, and that's 15 centimeters, for example. And then you ask me, where did you get the 15 centimeters from? And I'll tell you, I got it from the damn ruler, because that's what it does. That's what a ruler does. So bell-shaped curves, they're measuring tools. They're like protractors. So I got the 34% from the curve. The curve is telling me because I fit the curve to the stretch of the Apple Store wait time. And because I fit it to the stretch, I can now use all the superpowers of the curve. Okay. Every time you see the point between this bar and this bar in a normal distribution, it's going to look like that. So these are people who waited between 60 and 65 minutes, right? Right? People who waited between 60 and 65 minutes were 34% of all customers. If you're confused about this, you can go back to the all distributions class when we see that actually this curve is just fitted on top of a histogram. There's a moment where we show that this is fitted on top of a histogram, so you can rewatch that one. The percentages are already there. The percentages are also always the same. Okay, this is a question that people ask me all the time. Wait, so you're telling me that every time, like, that I fit a normal distribution to a histogram, the percentages are always going to be yes, they are. It's like, it's crazy simulation shit. Like Elon Musk might be right. Okay, so just keep that in mind. And that makes your that at least that makes your stat scores easier now. Now, again, people who waited between 65 and 70 minutes were 13.5% of all customers, right? And here, finally, people who waited between 50 and 70 minutes were 95% of the customers.